Alright, hi everyone and welcome to another episode of Moyo Math. This evening we're going to be looking at matrix transformations. Our exams in the next few days, and we want to ensure that if we see a question on matrix transformations, we're able to answer it comfortably and put ourselves in a good position to get that 1 with 3 A's in our profile in our Csec math examination. Alright, so let's look at some past paper questions in relation to matrix transformations. So let's get into it. So question 1. Write down the 2 by 2 matrix R, which represents a reflection in the y-axis. You have to know what is 2 by 2 matrices with regards to transformation. So the 2 by 2 for reflection in the y-axis will be negative 1, 0, 0, 1. So this is reflection in the y-axis. That's a part 1. Part 2. Write down the 2 by 2 matrix N, and of course this matrix here is R. So write down the 2 by 2 matrix N, which represents a clockwise rotation of 180 degrees about the origin. So if it's clockwise or anti-clockwise, it's the same 2 by 2 matrix for a 180 degree rotation about the origin. And that 2 by 2 it is negative 1, 0, 0, negative 1. And this represents a clockwise rotation of 180 degrees about the origin. Alright, let's look at part 3. Part 3 says, write down 2 by 1 matrix T, which represents a translation which is 3 units parallel to the x-axis. So 3 units parallel to the x will be moving this way to the left, and 5 units parallel to the y, meaning you're moving 5 units upwards. So you're moving to the left and you're moving upwards. So as a 2 by 1 matrix, this will be negative 3 because x must be written first, and 5. Right? So you have x, y, so that's a 2 by 1 matrix, negative 3, 5. So that's part 3. Let's look at part 4. The point P, 6, 11 undergoes the following combined transformations, such that Rn, which represents P, maps P onto P prime. So, and we have Nt, which represents P, maps P onto P double prime. They want us to determine the coordinates of P prime and P double prime. So, this point P, whose coordinates are 6, 11, undergoes a combined transformation. So, let's look at part 4. Let's start with the combined transformation Rn. Alright? Which also represents P. So it's going to be represented as P. So Rn is simply what we will multiply these 2 matrices Rn in the order in which it is stated. R, which is first, negative 1, 0, 0, 1 times n, negative 1, 0, 0, negative 1. And let's multiply those 2 matrices. Of course, those 2 matrices can be multiplied. They are compatible. And how do we multiply 2 matrices? Of course, we will take the rows of the first times the columns of the second. So we're going to multiply rows by columns. This will be negative 1 by negative 1 plus 0 by 0. So that's my first row, my first column dealt with. Let's take my second row by my first column, 0 by negative 1 plus 1 by 0. So we multiply, that's my first 2 rows of my first column dealt with. Let's take my first 2 rows with my second column, first row, second column, negative 1 by 0 plus 0 by negative 1. That's my first row, second column. Now my second row, second column, 0 by 0 plus 1 by negative 1. So when we multiply these 2 matrices Rn to give me P, this will be 1 plus 0, 0 plus 0, 0 plus 0, 0 plus negative 1. So the 2 by 2 matrix Rn will be represented by, that's the combination of those 2, is going to be 1, 0, 0, negative 1. Alright? So that is Rn. Now, Rn maps P onto P prime. So this Rn will mark, when we multiply Rn by P, of course, it's going to give us P prime. Alright, so let's multiply Rn by P to give us P prime. So for us to move from our object point to image point using this combined transformation, I'm going to multiply Rn, which is 1, 0, 0, negative 1 by the matrix P, and now I'm going to convert P from a row form to a column form, right? So you have your row format, which is 6, 11, running horizontally. You want to write it as a column format, which will be 6, 11. That's a column format. So let's multiply your 2 by 2 matrix represented by Rn. Good? So that's a 2 by 2 matrix representing Rn. The combined 2 by 2 matrix. And of course, let's multiply that by P to help us to determine what is P prime. So this will be again a 2 by 2 matrix times a 2 by 1 matrix. They are compatible. So the two inner numbers are the same, that's why they are compatible. And the outer numbers will tell us what is the order of the end result. When you multiply two matrices, it's important to carry out this process. I didn't do it for these two because these two are certainly compatible. So let's multiply. This is taking the rows of the first by the only column. So I'm going to multiply row by column. 1 by 6 plus 0 by 11. Second row by my only column, 0 by 6 plus negative 1 by 11. And therefore we're going to get P prime as 6 by 1 is 6 plus 0 by 11 is 0, 0 by 6 is 0 plus negative 1 by 11 will give us negative 11. So therefore we're going to get P prime as 6, negative 11. And we can rewrite it back in the row form. So therefore P prime will be 6, negative 11. Alright, so take the combined 2 by 2 and multiply it by matrix P to give us P prime. Let's look at NT. So let's get the combined transformation NT. I'm going to multiply that by P to give us P double prime. So let's get NT. So I'm erasing here, so we can do NT. So NT, we have the matrix N, we have the matrix T. So NT, we're going to multiply NT by P to give us P double prime, alright? So NT will be simply N negative 1, 0, 0, negative 1 times T negative 3, 5. Let's multiply this 2 by 2 by 2 by 1. Then they are compatible. Once the two inner numbers are the same, they are compatible. You can look at my YouTube video on matrices and you can see that. And the two outer numbers will tell us again the result is a 2 by 1 matrix. So the result will look like this. So let's multiply. I'm taking the rows of the first by my only column. So this is what? First row by my only column, negative 1 by negative 3 plus 0 by 5. And this is 0 by negative 3 plus negative 1 by 5. And this will give us negative 1 by negative 3 is positive 3. Plus 0 by 5 is 0. 0 by negative 3 is 0. Plus negative 1 by 5 is negative 5. This will give us 3, negative 5. And that will be the combined transformation NT. Yeah? Yeah? So the combined transformation NT, of course, will be what we have here, which is 3, negative 5, and of course the combined transformation NT will be a 2 by 1 matrix as you see, or a vector transformation, right? So what we want to do is to map P onto P double prime. So this NT representing P, you want to map that onto P double prime, P onto P double prime. So to do so, we are going to P whose coordinates are 6, 11, NT, this is the combined transformation NT. For us to map P onto P double prime, it means we have to add this 2 by 1 matrix to P to give us P double prime. So we're going to take P whose coordinates are 6, 11. We're going to add 3, negative 5, representing your combined transformation NT, good, onto P double prime. So this will be 6 plus 3 and 11 plus negative 5. And this will give us 6 plus 3 is 9. And a plus by a minus is a minus. 11 minus 5 is 6. So we're going to get P double prime. This is P double prime. We can state it in terms of the row format with 9, 6. So this here represents P double prime. Okay? And writing it back in the row form will be 9, 6 I'll show you. Alright, so that's our first question. Let's look at the second. So we have here, so don't forget everyone, make sure to like, share and subscribe to the channel. Make sure you like, share and subscribe. Let's look at the second. A transformation T is defined by the matrix T, whose elements are 2, negative 1, 2, 0. And it says here the point A whose coordinates are negative 2, 3 is mapped onto A prime, whose, of course, coordinates are AB. Right? Under T, we're going to map A onto A prime. So they want us to find the value of A and B. So we're going to map T, onto A prime using the transformation T. In order for us to do so, we're going to take the transformation T, we're going to multiply by A to give us what? A prime. And A prime, of course, will have our knowns A and B which we need to determine. So we're going to take T whose elements are 2, negative 1, 2, 0 times A whose elements are, well, coordinates are negative 2, 3, but we're going to write it in the column format, so it's going to be written as negative 2, 3. And let's multiply T by A to give us A prime. So of course, this is a 2 by 2, 2 by 1, 2 inner numbers are the same. The 2 outer numbers will give us a 2 by 1 matrix as our end result. And how do we multiply? Take the rows of the first by the only column. So this will be first row by our only column, 2 by negative 2 plus negative 1 by 3. And my second row by my only column, this is 2 by negative 2 plus 0 by 3. This will give us 2 by negative 2 is negative 4 plus negative 1 by 3 is negative 3. 2 by negative 2 is negative 4. 0 by 3 is 0. So we're going to get negative 4 subtract 3. And this is negative 4 plus 0. Which will give us negative 7, negative 4. So it means that A prime will be negative 7, negative 4. When I multiply T by A, the result is what I have here, which represents A prime. And we can state therefore A is negative 7 and B is negative 4. So that's part 1. And they want us to now determine the matrix transformation that maps A prime to A. What is the matrix transformation that maps A prime to A? So looking at part 2. So the matrix transformation that maps A prime to A is simply we have T multiplied by A, and if we have to make A the subject to get A by itself, which will allow us to map A prime onto A, we need to get A as the subject. It means we will remove T. When I remove T, T comes across to the right as T inverse. And I must place T inverse in front of A prime. So when I multiply the inverse of T by A, it's going to give me, when I multiply the inverse of T by A prime, it's going to give me. So when I ask us to determine the transformation matrix that maps A prime to A, transformation matrix will be this matrix, which is the inverse of T. And let's go find it. Let's find the inverse of T. T is equal to 2, negative 1, 2, 0. So T inverse will be 1 all over your determinant times the adjoint. D and A interchange, change the signs of B and C. So this will be 1 all over A, which is 2. Remember, this is A, B, C, and D. A, which is 2. D, which is 0. Subtract B, negative 1. C2 times the adjoint, which is the interchange both A and D, 0, 2, and we change the signs of B and C. So we know that negative 1 becomes positive 1, and positive 2 becomes negative 2. So this is 1 all over 0, subtract negative 2 times the adjoint. This is 1 all over A minus by A minus is A plus, so we're going to get a half times 0, 1, negative 2, 2. So when I multiply a half by the adjoint, I'm going to get 0, a half, negative 1, 1. So that there is the 2 by 2 matrix, which represents the inverse of T, and the inverse of T helps us to map A prime onto A. So that is the inverse function, the inverse matrix. Now part 3, another transformation P is defined by 0, 1, 1, negative 2. Find a single 2 by 2 matrices that represents a combined transformation T followed by P. So what is a combined transformation T followed by P? Now when you see that in a transformation question, what it means? So we have here part 3. So another transformation P, so we have two matrices. We have one T, the matrix 2, negative 1, 2, 0. We have one P, the matrix 0, 1, 1, negative 2, right? And what I want us to do is to find a single 2 by 2 matrices that represents a combined transformation T followed by P. So when I tell you T followed by P, what students often will make the mistake and they say TP, because by reading you will obviously think T followed by P should be stated as T then P. But really, when they state T followed by P in a transformation question, it simply means when it's stated in the order PT. Right? So T followed by P means P will be written first, T will be written after. So they want, for part 3, the single 2 by 2 matrices that represents a combined transformation T followed by P is going to be stated as PT. So let's determine what is that combined transformation. So A, you know P, it is 0, 1, 1, negative 2 times T, 2, negative 1, 2, 0. And let's multiply those two matrices and take the rows of the first by the columns of the second. And of course, these two matrices are compatible. Let's just show this is 2 by 2. That's 2 by 2. The two inner numbers are the same. The outer numbers will tell us the end result is 2 by 2. So let's multiply. Taking the rows of the first by the columns of the second. So I'm taking first row, first column, 0 by 2 plus 1 by 2 first row, first column. Now let's take my second row, first column. This was 1 by 2 plus negative 2 by 2. Now let's take my first two rows by my second column. This is 0 by negative 1 plus 1 by 0. And second row by my second column, 1 by negative 1 plus negative 2 by 0. And let's see what we're going to get here for our single 2 by 2 matrix representing the combined transformation T followed by P. And this will become 0 plus 2, 0 plus 0, 2 plus negative 4, and negative 1 plus 0. So you're going to get what? 2, 0, a plus by a minus is a minus, 2 minus 4 is negative 2, and we're going to get negative 1. So that is our combined transformation, right? Representing T followed by P. Remember, we stated as PT. Make sure P is written first, T after. And now we want us to hence find the image of the point 1, 4 under this combined transformation. So what's the image of the point 1, 4 under that combined transformation? So I'll write part B here. So the image is simply to multiply our 2 by 2 representing the combined by the point 1, 4, coordinate 1, 4 to give us the first term. What's the image of that point? So this will be our 2 by 2 matrix. 2, 0, negative 2, negative 1. I'm going to multiply that 2 by 2 matrix by the point 1, 4, and I'm going to not write as the row form, but column form. And we can name that point if you want to call it, M. And when we multiply that 2 by 2 by the matrix M, which we have written in the column form 1, 4, that will give us M prime. So let's multiply. So this is 2 by 2, 2 by 1, 2 inner numbers are the same. The outer numbers will be 2 by 1, and let's multiply. The rows will be first by our only column. So this is 2 by 1 plus 0 by 4, negative 2. This is our second row by our only column, negative 2 by 1 plus negative 1 by 4. So we're going to get 2 plus 0, negative 2 plus negative 4, and we're going to get 2 plus 0 is 2, a plus by a minus is a minus, negative 2 subtract 4 will give us negative 6. So clearly it means here that the image of the point 1, 4 will be 2, negative 6 under that combined transformation. Alright, so the answer here, which I'm going to call M prime will be equal to 2, negative 6. And we can write it back in the row form. Alright, so that's question 2. Let's look at another question. So we have a question 3. Under a matrix transformation M, A, B, C, D, the points V and W are mapped onto V prime and W prime such that V, whose coordinates are 3, 5, is mapped onto V prime 5, negative 3, and W, whose coordinates are 7, 2, are mapped onto W prime 2, negative 7. Determine the values of A, B, C, and D. So we have to determine the values of A, B, C, and D. So what are we going to do here? So under this matrix transformation M, the points V and W are mapped onto V prime and W prime. So what we can do here is set up an equation to help us find A, B, C, and D. So how do we set up our equation? It's going to be the matrix M times the 2 points whose coordinates are for V3, 5 and W7, 2. So this will be VW times M times VW will give us V prime W prime. Yeah? So under this matrix transformation M, the points V and W are mapped onto V prime and W prime, right? So we want to determine what are the coordinates of A, B, C, and D. So that we determine what is M. Alright? So how are we going to determine what is M? Of course, we have our equation there. M, whose coordinates are A, B, C, and D, times VW. So what I'm going to do, I'm going to state VW. I'm going to convert my row form into the column form. This is V3, 5. This is W7, 2 is equal to V prime converted from the row form to the column form. So V prime will be 5, negative 3. W prime 2, negative 7. And if I have to determine A, B, C, D, this is what I'm going to do. I have to remove my VW over to the right of my equal sign. But when I remove my VW, it comes across to the right as the inverse. But because I am post-multiplying, post means after, I'm post-multiplying VW by M, when I bring across VW as the inverse, I have to post-multiply the inverse by V prime W prime. So M will be equal to V prime W prime times the inverse of VW. And the inverse of VW, of course, will be written after V prime W prime. Alright, so when you remove VW, because you're post-multiplying VW by M, when you bring across VW as the inverse, you have to post-multiply the inverse by V prime W prime. So therefore, it's written after V prime W prime. So let's find the inverse of V prime W prime. Let's find the inverse. Yeah? So this will be V prime W prime. The inverse of that will be, sorry, VW inverse will be equal to 1 all over your determinant times your joint. So this is 1 all over. This is A, B, C, D. A, of course, will be 3. D will be 2. Subtract B is 7. C is 5. Multiply by the adjoint. I'm going to interchange both A and D. I'm going to change the signs of B and C. So this will be 1 all over 6 subtract 35 times 2 negative 7 negative 5 3. So this will give me 1 all over 6 minus 35, that's what? Negative 29 times 2 negative 7 negative 5 3. And therefore VW, the inverse of that will be 2 over negative 29, 7 all over 29, 1 over negative 29 by negative 7 is 7 over 29, 1 over negative 29 by negative 5 is 5 over 29, 1 over negative 29 by 3 is 3 over negative 29. So I'm going to multiply the inverse of VW by V prime W prime to determine the coordinates of M, A, B, C. Alright? So let me multiply that by V prime W prime, is what I have here, and let's see what we're going to get. So this will become, so I'm going to write it here as a total here. So this will be V prime W prime, we have as 5, 2, negative 3, negative 7. And I'm going to multiply that by VW, the inverse of VW, which is 2 all over negative 29, 7 all over 29, 5 all over 29, and 3 all over negative 29. So let's multiply this. I'm taking the rows of the first by the columns of the second, and let's see what we're going to get. This will be 5 by 2 all over negative 29. So 2 all over negative 29 times 5 plus 2 by 5 all over 29. So that's my first row, first column dealt with. And it's going to be second row by my first column. This is negative 3 by 2 all over negative 29 plus negative 7 by 5 all over 29. That's my first two rows of my first column dealt with. Now let's take my first two rows with my second column. So this will be 5 by 7 over 29. So that's 5 by 7 all over 29 plus 2 by 3 all over negative 29, which is that's negative 6 all over 29. Then second row by my second column, negative 3 by 7 over 29 is negative 3 by 7 over 29 plus negative 7 by 3 all over negative 29. So we simplify that. What are we going to get? This will become, because I have my two sets of brackets, so this will become negative 10 all over 29 plus 10 all over 29. This will be 35 all over 29 minus 6 all over 29. This will be negative 6 all over 29, in fact positive 6 all over 29 plus negative 35 all over 29. This will be negative 21 all over 29 plus 21 all over 29. When we work that out, what are we going to get for A, B, C, and D? So this will be negative 10 plus 10 is 0, so 0 over 29. Once the denominators are the same, you can maintain the denominators, so that's 0 over 29, which is 0. The denominators are the same, so you maintain the denominators. 35 minus 6, you can subtract the numerators, so it will be 29, so that's 29 over 29, which is 1. 6 minus 35 is negative 29 all over 29, and that is negative 1. And negative 21 plus 21 is 0, so you're going to get 0 all over 29, which is 0. Alright? And that there will be our representation for A, B, C, and D. So we know that A will be 0, B will be 1, C is negative 1, and D is 3. So we have found A, B, C, and D. Alright? So we have next, state the coordinates of Z. So let me erase here. So state the coordinates of Z such that Z to Z prime on the, alright, so they want us to state the coordinates of Z such that ZXY to Z prime phi 1 under the transformation M. Good? So state the coordinates of Z, so they want us to find the coordinates of Z, which is mapped under Z prime phi 1 under the transformation M. Okay? So M, so this is part 2. So this was part 1, so some working to do there. So state the coordinates of z. So M map z onto z prime. Good? And we want to determine the coordinates of z. So M, we got M to be 0, 1, negative 1, 0. And this obviously maps z onto z prime. We put an equal sign, whose coordinates are 5, 1. So we want to determine z, right? To state the coordinates of z. So to state the coordinates of z, again, this is what we're going to do. This is to get z by itself, it means we have to remove m. And when we remove m, m comes across as m inverse. Good? So m inverse will help us to, when we find m inverse and we multiply that by z prime, it's going to help us to determine what are the coordinates of z. So we're going to bring m over to the right as m inverse times z prime. So we have to find the inverse of m and we will multiply that by z prime. So let's find the inverse of m. So the inverse of m, of course, will be 1 all over on the determinant times the adjoint. So interchange both a and b, change the signs of b and c. This is 1 all over, this is a, b, c, and d. So it's going to be 0 by 0. Subtract 1 by negative 1 times the adjoint, interchange both a and b. Change the signs of b and c, so positive 1 becomes negative 1, negative 1 becomes positive 1. So this will be 1 all over 0, subtract negative 1 times 0, negative 1, 1, 0. And therefore this will be a minus by minus is of plus 1 over 1 is 1. So 1 times 0, negative 1, 1, 0. So that is n inverse. So therefore, for me to get z now, I'm going to multiply m inverse, which is 0, negative 1, 1, 0, by z prime, 5, 1. Let's multiply those two matrices to help me to determine what is z. So this will be the rows of the first by the only column. So of course they are compatible. This is 2 by 2. That's 2 by 1. 2 and the numbers are the same. So my end result is a 2 by 1 matrix. So let's multiply to determine what z will be equal to. So this will be, let me erase that, let me do it on this side. Right, so I've ended it. So I'll continue on this side. So this will be z is equal to row by column 0 by 5 plus negative 1 by 1. Then we're going to have second row by my only column, this is 1 by 5 plus 0 by 1. So z will be equal to 0 plus negative 1, and this is 5 plus 0. So z is equal to negative 1, 5. Yeah? So the coordinates of z, so what is the state? The coordinates of z, such that z, when mapped onto z prime under the transformation m, right? So the coordinates of z will be negative 1, 5. Okay? So make sure we understand in terms of our matrix transformations, you know, when you're multiplying the 2 by 2 matrix by the object to give you the image, sometimes they ask you to determine what is the object given the 2 by 2. Alright? Transformation, 2 by 2 matrix transformation. And what we have to do here is, of course, is to place the matrix transformation over to the right, which comes across as the inverse. And we're going to multiply the inverse by the image C prime in this case to help us determine what's the object C. Alright? So very, very important. So let's move on to the next question. Right, so a geometric transformation R maps the point 2, 1 onto negative 1, 2. Given that R whose coordinates are 0, P, Q, 0, calculate the values of P and Q. So this geometric transformation R maps this point P, which is the object, point 2, 1, which I have called P, right? 2, 1 onto negative 2, negative 1, 2, which represents its image. Given that R has a 2 by 2 matrix, 0, P, Q, 0, calculate the values of P and Q. So we want to find the values of P and Q. Let's find the values of P and Q. Right, so a geometric transformation R, so we're going to maps the point 2, 1 onto negative 1, 2. So R maps the point 2, 1, let me call that P, onto negative 1, 2, let me call that P prime. Then R, it is 0, P, Q0 times point P whose coordinates are 2, 1 to give us P prime, which is negative 1, 2. Remember, you are not going to write it in row format, you have to convert it into the column format. Alright? So they want us to find the values of P and Q. So what we can simply do here is to multiply these two matrices, create a pair of equations, or create equations help us to find P and Q. Simple. So this will be, let's multiply rows by my only column, 0 by 2 plus P by 1, and this is second row by my only column, 2 by Q plus 0 by 1. This will be equal to negative 1, 2. So we're going to get 0 by 2, 0, plus P by 1 is P, 2 by Q is 2Q, plus 0 by 1 is 0, and this is equal to negative 1, 2. What we can do here is simply create a pair of equations, 0 plus P is P, 2Q plus 0 is 2Q, is equal to negative 1, 2, and we can easily find P and Q, therefore equating P is equal to negative 1, and we can easily find Q again equating 2Q is equal to 2, so Q is equal to 2 divided by Q, Q is 1. So we have found the P and we have found the Q, so therefore P is negative 1 and Q is 1. So making sure that we set up our equations correctly. So this here is a case where we're taking the geometric transformation R, which is a 2 by 2 matrix, and we're going to map P onto P prime. So this is the equation setup to help us to do so. And what we will do in turn is create a matrix equation, and we use the matrix equation to help us to find what is required. So let's look at part B. A translation T whose elements are R and S maps the point 5, 3 onto 1, 1. Determine R and S. Now because it's a translation, we have to know what is the formula for a translation, which is where we take the translation, we're going to add it to the object points to give us the image points, and that can then help us to find the unknowns T and S. Good? So let's look at it here. So let me state what is R here. So we know R, so I'm going to make sure I put what is R here. R, so looking at part C, R it is 0, P is -1, Q is 1, and 0. Alright, so that is the R. So moving on to part B. And I'm giving this here because we have to apply R to part C of the question. So part B, a translation T maps the point 5,3 onto 1,1. So again, what is a translation? It is going to be your translation plus your object will give you your image. The translation is RS plus the object will be 5,3 and that will be mapped onto the image 1,1. So they want us to determine the values of R and S. Simple. To define R and S, what we can do, we can subtract, again RS as the subject, we can subtract 5,3 from both sides. So it will be 1,1, subtract 5,3. So RS will give us 1 subtract 5, 1 subtract 3. So RS will be -4, -2. That is what RS is equal to. Simple formula for translation. And part C, determine the coordinates of the image under the combined transformation R followed by T. So determine the coordinates. So in a case as such, now we know normally when we talk about R followed by T, you know, most times we think of, and it's correct thing to do, you put T first, then R after. We have to be very careful, especially with these two matrices. R is a 2 by 2, and T, this is T, is a 2 by 1 matrix. So if we place it in the order TR, that would make sense, because we cannot multiply T, which is a 2 by 1, by R, which is a 2 by 2. They are not compatible. Alright? So we cannot state it in that order as TR, because R is a 2 by 2 and T is a 2 by 1. So what we have to do, in order for us to determine the coordinates, we have to do it individually. Alright? So we're going to carry out R first, get the result, and then we're going to carry out T after. Alright? So we're not going to combine them, combine the two matrices, because that cannot be done. Alright? So we know T is equal to -4, -2. So let's carry out the transformations individually. Alright? We cannot combine the two transformations. We have to do it individually. So determine the coordinates of the image of 8, 5. So we have 8, 5, let's call it A. So let's determine the image of 8, 5 under the combined transformation starting with R. So R is a 2 by 2 matrix, and when it's a 2 by 2 matrix, it means it's applicable to reflection, it's applicable to rotation, it's applicable to enlargement. So it's going to be, the formula will be to multiply R by A, which will give us A prime. R is 0, -1, 1, 0, times A, 8, 5, I'm going to convert it into what? Column form. And let's multiply those two to give us A prime. So this is what? 2 by 2 by 2 by 1. The two other numbers are the same. We connect the outer to give us a 2 by 1 matrix. Let's multiply rows of the first by the only column. So 0 by 8 plus -1 by 5. 1 by 8 plus 0 by 5. And we're going to get to A prime as 0 plus -5, 8 plus 0. So we're going to get -5, 8 as A prime. Okay? But then, that is R being applied to. But then we have followed by T. So let's move from A prime to A double prime. Okay? So followed by T will be to take A prime, we're going to take the transformation, remember to take the translation, once it's a translation, we're going to add it to A prime, to give us A double prime. I've just named it A double prime, A prime and so on, right? So the translation T is -4, -2, which I'm going to add to A prime, which is -5, 8, to give me A double prime. And this will be -4 plus -5 in brackets, and this is -2 plus 8. So A plus by A minus is A minus, that's -4, subtract 5, -2 plus 8, that will give us -9, 6. Alright? And this will be the image of, now call that A double prime, so A double prime will be -9, 6. So this will be the image of A5 under the combined transformation R followed by T. Remember, we cannot combine these two transformations because when they state R followed by T, you have to take the latter, put it first. That means T will be first, R will be after. And we cannot multiply the two matrices in that order, TR. They are not compatible. So therefore, in order for you to show the combined transformation, it has to be done individually. So you deal with R multiplied by A, I've called it A to give you A prime, and then you show where you carry out the translation T plus A prime to give you A double prime, which will be the final result. Okay, so let's look at one more question. So looking at matrix transformations here. So carrying out your operations on matrices, addition, subtraction, multiplication, and of course, applying your knowledge of transformations as well. So it says here, the diagram we will not drawn to scale shows a triangle ABC with coordinates as stated. Triangle ABC undergoes two successive transformations, V followed by W, where V is 2, 0, 0, 2, and W is -1, 0, 0, 1. State the effect of V on triangle ABC. So the effect of V will be the triangle ABC. This is the triangle ABC here. Yeah? And the effect of V on triangle ABC, this will be an enlargement. Because when we see the setup like this, for an enlargement 2 by 2 matrix, it's an enlargement. So the state effect of V on triangle ABC, V will be an enlargement of scale factor 2. Alright? An enlargement of scale factor 2. Because for enlargement, the 2 by 2 matrix for enlargement is K00K, where K is equal to your scale factor. So the scale factor here is 2, so this will be an enlargement. Alright, so that's part 1. Part 2, determine the 2 by 2 matrix representing the combined transformation V followed by W. Alright, so V followed by W. Now we can combine it in the order WV because both are 2 by 2 matrices and I can multiply to get a single 2 by 2 representing the combination of the two. So this will be W first, and this is V followed by W. Remember W first, then V after. So this is -1, 0, 0, 1 times V 2, 0, 0, 2. And let's multiply. Rows are the first. by my columns of the second. This is first row, first column, negative 1 by 2 plus 0 by 0. Second row by my only column, 0 by 2 plus 1 by 0. Then my two rows by my second column, negative 1 by 0 plus 0 by 2. Then my second row by my second column, 0 by 0 plus 1 by 2. When I work it out, what are we going to get? What is the single 2 by 2 representing the combined transformation V followed by W? This is negative 2 plus 0, 0 plus 0, 0 plus 0, 0 plus 2. And this will give us negative 2, 0, 0, 2. So that's a 2 by 2 matrix representing combined transformation V followed by W. Okay? And part 3, using your matrix in 2, determine the coordinates of the image of triangle ABC under the combined transformation. So under the combined transformation means we are going to multiply this 2 by 2 by the object point, which is of course a triangle ABC, to determine what will be the image points, right? And A has coordinates 1, 2, B has coordinates 1, 1, and C has coordinates 2, 1. Okay? So let me state what is this 2 by 2, this combined 2 by 2. Alright? And let us now look at part 3. So part 3, they want us to take the combined transformation and determine what are the image points of ABC. So we take the combined transformation, we're going to multiply it by the object, which will be A, B, and C, and we can convert those coordinates from its row form to column form. So this is A1, 2. B 1, 1, C 2, 1. And let's multiply those two matrices to determine what will be A prime, B prime, C prime. So this will be rows, and let's see if they're compatible. This is 2 by 2. This is 2 rows and 3 columns. So they are compatible because the two inner numbers are the same. The outer numbers will tell us that the end result will be a 2 by 3 matrix. So this will help you to get your A prime, B prime, C prime, which will be the image of ABC. So let's multiply rows of the first by the columns of the second. So this is first row by my first column, negative 2 by 1 plus 0 by 2, first row, first column. Now my second row, first column, 0 by 1 plus 2 by 2. Then my two rows of my second column, this is negative 2 by 1 plus 0 by 1. Then my second row by my second column, 0 by 1 plus 2 by 1. And then my two rows by my last column, this is the first row, last column, negative 2 by 2 plus 0 by 1. And then the second row by my last column, 0 by 2 plus 2 by 1. And therefore, what are we going to get? Negative 2 by 1 is negative 2 plus 0. This is 0 plus 4. Negative 2 plus 0. 0 plus 2. Negative 4 plus 0. 0 plus 2. So when we simplify, we're going to get A prime, B prime, C prime as negative 2, 4. A prime, negative 2, 2, B prime, negative 4, 2, C prime. So we know that A prime will be negative 2, 4, B prime, negative 2, 2, C prime, negative 4, 2. and we have the image of triangle ABC. Alright, so this will bring us to the end of matrix transformations. I hope that you were clear on what was done here in relation to matrix transformations. Please look at the video again, make sure that there's clarity. Don't forget to like, share, and subscribe to the channel. Remember, it's all about achieving a 1 with 3 A's on our profile. And please look at the channel, look at Moyo Man to help you to do so. Alright, so that said, have a great evening. Take care, everyone. Bye.